today's video, I'm going to show you how to do static structural analysis on Ansys Workbench. Now, when you open the Ansys Workbench, the interface looks like this one. Here it is project schematic. Here we do have toolbox, and then after we do have some errors and also progress showing box or dialog boxes is there. Now in this project or in this analysis, I'm going to perform this static structural analysis on Crankshaft. Now let me come to the static structural and take this one, and then after drag into the project schematic and drop. Now the first thing is static structural types of the analysis. The second row is engineering data. By default, Ansys Workbench use structural style for material type, so that one is checked. Now we have a right sign there. Now the third step is to import or to develop a geometry. In our case, let me go to the my directory and import the crankshaft geometry that I developed. Here we do have the crankshaft, so click this one and open. Now the geometry is checked. Then the first step is to model. So we have to come to this one and right click, and then after update. Okay. Now here the progress of the update is here. It is shown when you bring the cursor on the progress sign, so it shows the percentage of the progress of the model. Now here the model update is finished. The fifth step is to set up the boundary conditions and the load that we need. Double click this setup. The setup is opening, and zoom out. So the crankshaft geometry looks like the one that you are seeing on the screen. We do have this geometry, and here coming to the mesh. Now the geometry is checked, the material is checked, the coordinate system is checked, the mesh is by default. Ansys takes some default kinds of meshing, or directly we go to the static structure, because here the question sign is there here, and also on solution. So let me come to this one and right click, then insert the fixed boundary condition, fixed support. Okay, then select this one. Here I'm going to provide the fixed support on this face. Okay, now select the surface, the face. Here I'm going to select this one. Okay, that one is selected. Here on the details of fixed support, I have the geometry, so I have to apply my selection. So apply the selection, and then now the fixed support is applied. The second step is to apply the load, or in our case, we're going to apply the moment. Right click, insert, and then after here we do have a moment. Okay, so click this one. So I'm going to apply the moment at the other end. So click in the geometry, click this one, then after apply. So this face is applied, is taken as the one that is the moment is applied on. Then now we have to provide the magnitude of the moment. So here from defined by, so we do have a vector. Now let's change this one to component. That means, okay, we do have those components So I'm going to apply this moment upon the z-axis. So in our case, let me simply apply 1000 Newton per meter on this z-axis. Now, when you see this end, that amount of moment is applied. Now we finished the boundary condition and also the load application. So in that sense, here we do have those three elements that we have is checked with right sign. Now the last step is to come to the solution and provide the solution that we need. In our case, I need deformation, total deformation and stress. So right click this one, then go to deformation, and then after total deformation. Now total deformation is selected. The second one is insert, then stress. From stress, the first one, that one is equivalent von Mises stress. I have to select this one, then selected. So now we finished all the application of the necessary preprocessor or preprocess of the analysis. Now we have to run the solution. Okay, then solve, right click, then solve. Now the problem is ongoing. Here at the left lower end, we have this bar that shows the percentage of the analysis. Now it is on 10%, and at this stage it is building the mathematical model. Now it is finished. The analysis is finished. Now let me little bit zoom in and to show it, and I pan it and bring it at the center. Okay, here let me change this pan sign by selecting this mode, and then after single select, now come to the total deformation. Here, as we see, the total deformation of the analysis is 0.001643. This one is the maximum. The maximum is at this point. So the maximum deformation of this crankshaft is at this end. So this one is in the case of total deformation. The second solution that we have is of the equivalent stress. Select this one. Now you see here the maximum stress upon the member is here at this end, where the moment is applied. Then here, when you see the magnitude of the or the maximum stress induced in the member is 9.38 Pascal. Okay, now this is all about the static analysis when we apply the moment as a load on the crankshaft.